Good afternoon, everyone. My name is Klara Viljeon, and the project I'm presenting is called Hydro-Pneuma. This design explores the vital relationship between water, environment, and human experience, aiming to foster a deeper appreciation for water conservation. If you want to build a ship, don't drum up the men to gather wood, divide the work, and give orders. Simply teach them to yearn for the vast and endless sea. This quote directly relates to creating a deep, lasting desire to save water by emphasizing that true change comes from igniting a passion for the cause, rather than simply instructing people to act. As designers, instead of relying on the typical save water posters, we should focus on inspiring people to connect emotionally with the idea of preserving water. By evoking a sense of urgency, we can create a more meaningful connection to the cause. This leads to my design question. How can hydrophilic architecture within the sites educate visitors about water scarcity, cultivate a sense of hydro-gratitude, and promote sustainable water practices? Additionally, how can the design foster social resilience by encouraging community engagement and empowering visitors to take water-conscious actions, both within and beyond the site? So let's take a look at the precedents. The first precedent takes place in Dorze, Ethiopia, called Waka Towers. This is inspired by the fog beetle shell, which mimics its hydraulic and hydrophobic properties to efficiently capture and store water from the air, offering a sustainable solution for water scarcity in arid regions. The second precedent takes place in the south of Iran. Concave roof structures serve as a very powerful precedent, coalescing raindrops and standing as a constant visual reminder of water harvesting through their prominent designs. And the last precedent, called the Bamboo Pavilion in China, revitalized the waterfront space with its striking structure, fostering social vitality and drawing people in through its unique and inviting design. These three precedents highlight the integration of sustainable water harvesting through innovative design, the visual impact of water conservation, and the power of architecture to foster social vitality and human connection to the environment. Landscape approaches. My landscape is informed by three main strategies. Hierarchy. This shapes pathways through scale, program, and the emotions they evoke. Next is topographic integration, addressing infill and cutout to blend with the terrain. And lastly, juxtaposition, exploring contrast not only in materials but also between humid and arid conditions. The pathways are divided into a hierarchy. Primary paths are informed by axial linkage. They transect the site, unifying it with adjacent spaces and existing zoo pathways. The curved design of the roads blends seamlessly with the site's topography and existing paths. Topographic integration harmonizes with the landform. And then lastly, tertiary paths divide spaces to define and support the program. Here is a collective depiction of all paths and programs. Next, we'll look at how water also informed the layout of the landscape. The pathways follow an axial route from south to north and east to west, guiding visitors through a transition from dry gardens to lush, vibrant landscapes, symbolizing the shift from scarcity to abundance. Gentle curves also mimic water's fluidity, enhancing the natural environment through the space. I intended to create a constructed wetland. So the largest benefit of a wetland is its role in enhancing biodiversity and water management. This was also a topographical choice as the wetland occupies the site's lowest point, historically also serving as the elephant's water hole, making it a natural and fitting location for this feature. I've selected 6 main plants for the wetland. They all share key characteristics in their ability to support diverse wildlife. These plants provide crucial habitat and nourishment for a range of animals, including birds and insects and small mammals, by offering food sources like seeds and nectar, as well as shelter. Their presence enhances the wetland ecosystem, attracting species that thrive in these rich biodiverse environments, furthering the site's ecological vitality. The 3 water-wise gardens were designed with the low-maintenance plants like aloes and succulents, chosen for their resilience and ability to attract wildlife. The ground will be covered in pebbles to further reduce water usage and maintenance. These gardens are then rated out of 5 based on their height and sun exposure, with calculations provided to guide plant selection. Higher plants are placed towards the back of the gardens to create depth and allow unobstructed views for the shorter plants in the foreground. A shadow study was then conducted to ensure optimal placement, and the layout correlates with the main site design, ensuring each garden's placement complements the overall site structure and enhances the ecological flow. The water catchment structure will be designed to draw inspiration from precedents, serving both as functional water collectors and subconscious reminders of the importance of water. The base structure, designed for visual appeal, will allow the application of specific parametric designs, which we will see later. Nylon mesh nets will then be added to the structures near the wetlands, providing support for creepers to grow, which will attract biodiversity. This design will respond dynamically to the seasons, with plants degrading in the winter and to allow for more sunlight. As seen in previous precedents, the structure will definitely have a positive social impact, drawing people in with its interactive and evolving nature. These parametric designs are inspired by various elements, including the forms of leaves and flowers, African drum rope patterns, and woven baskets, creating a unique blend of nature and cultural references. All elements of the design maintain a concave form to maximize water collection, channeling rainfall into the structure's center and ensuring efficient retention and flow, while also reinforcing the visual and functional relationship to water conservation. The placement of these structures is strategically aligned with the wetlands, where increased water vapor and airborne moisture enhance their ability to collect the maximum amount of water particles on site. These will particularly have nylon mesh to capture as much dew and air vapor as possible. A higher density of structures is placed in this area, marking the lowest point on site, which helps significantly to reduce water runoff and flooding by capturing and managing excess water. This distribution of the structures is guided by sun exposure, optimizing passive heating and shading, while placing social nodes in areas that promote interaction with thermal comfort. The elephant enclosures will serve as primary water harvesting structures, capturing and managing water effectively. Designed as educational nodes, they will raise awareness about water conservation. Water collected will be channeled above ground as visual reminders and underground into French draining systems, which filters and purifies water before directing it to the wetlands or repurposing it for irrigation. This integrated approach promotes sustainable water management while educating users on the critical value of water in maintaining environmental balance. Screens will display the water status of each structure, showing usage details such as hand washing and ablution consumption, while transparent piping enhances awareness of water scarcity. So the structures, including the elephant enclosures, bioswale, French drain, and wetland, will collectively capture approximately 338,000 litres of water per year, water that was previously not captured. To put this into perspective, this amount could irrigate around 135,000 square meters of garden, or provide approximately 338,000 hand washings. Additionally, it could flush a toilet about 42,000 times. The water collection plan illustrates the various proposed water systems on site, including the primary harvesting structures, bioswale, French drain, and wetland, highlighting how each system can contribute to the efficient water capture and management. Lastly, this is the final concept: integrating pathway approaches, sensory experiences of water, and structural catchment strategies into one cohesive concept, and thereafter, the final plan. By seamlessly blending architecture, landscape, and water systems, my design not only creates a visually and sensory stimulating journey, but also embeds a very deep, lasting connection to the critical importance of water conservation. Through this immersive experience, visitors are not only educated, but are also inspired to take action, fostering a collective sense of responsibility for preserving our most vital resource. As they move through the space, the stark contrast between scarcity and abundance serve as a powerful reminder of the impact of our choices can have on the environment, and ultimately driving a shift towards a more sustainable, water-conscious living. By looking at the final perspectives, one can see that the experience begins with tactile sensations of cracked earth underfoot, the oppressive dryness of the air, and the palpable tension of scarcity. As visitors progress, they are gradually enveloped in increasingly moist, mist-laden spaces, leading to an immersive, sylvan environment abundant with lush vegetation. Through shifts in sound, texture, and temperature, such as the echo of dripping water in arid surroundings, and the transition from rough, dehydrated to smooth, water-infused surfaces, the design amplifies the emotional impact of water's rarity. This progression from drought to abundance fosters a sense of hydro-gratitude, encouraging visitors to reflect on the fragility of water and inspiring sustainable practices in their own lives.